Well, hello from Emerald Hill Skies. My name's Doug. We're coming to you from the outskirts of Louisville, Kentucky on a very inky black night with no moon. And you know we love moonless nights. We try to make a big deal about the fact that we don't give up when the moon's out. But boy, when it's not, wow, is it more fun to see those very, very faint nebulae. Well, hello from Emerald Hill Skies. All right, looks like our audio's working, huh? Tiffany, good to have you here. You are so faithful. You knew that we'd be here. I wondered if we should go ahead and try it tonight, and then I just saw the clarity of the sky, and I said, we have to get out there and try it. We are finished, I think, with our autofocus, so we can jump out of Nina. Let's disconnect the equipment there. Get rid of the focuser connection to Nina, and disconnect the camera from Nina, and then bring up, let's see, do I already have a sharp cap set up for the main camera, the ZWO ASI2600MC Pro? You guys that have been with us before, you know we operate from a Tele-Station 2 by Pier-Tech on an adjustable height pier, and then on the end of that RASA 11 that you see pictured there, on top of an iOptron CEM70G mount, we've got this ZWO ASI2600MC Pro on the end of that RASA on an Octopi-Astro interface. And on top of the RASA, we have this neat little 178 that gives us these sky views. It's a ZWO ASI178. But right now, we're aimed at the North Star. That's Polaris that you see there. And that's the bright one right here. So let's get to our first target. Let's go to the object number 40 on the Cosmic Challenge list by Phil Harrington. It's the California Nebula. And let's see, I think we're ready to slew there. The other night I had the worst time finding slew to object in that right menu, and so happy to find it. I'm gonna have to go get my my little stool that I use to hold the book. Little stool I use to hold the book, Cosmic Challenge. And just for orientation, we're using this book by Phil Harrington, Cosmic Challenge, to work our way through the night sky. His list is organized in several different kinds of levels: naked eye, binocular, 3 to 5 inch, 6 to 9 inch, 10 to 15 inch, and then what he calls monster scopes, 16 inches and up. So that's how his books are organized. Good to see you there, Ricky. Oh my goodness, the Shih Tzu's got a bath today. Tiffany, that sounds awesome. Tai Kim, do stars give off sounds? Well, some do. They are radio sources, so they make electromagnetic pulse, just like a radio would. Tai Kim, good to have you aboard. I forget where you're talking from, Tai Kim. You told us once, but now I forget. Please forgive me. All right, so let's do a plate solve here. You know what I've wanted to do? I've wanted to turn the plate solving on for the plate solving now built into SharpCap, and I just don't think I've done it yet. Let's go and look at it real quick and see if it's easy to turn on. The other day I came here and I couldn't find it. Plate solve. Select plate solving application. Yeah. Where do you turn it on SharpCap? I don't see it. Well, we're not going to worry about it. We're going to keep using ASTAP, but I have to find out where that is. Maybe it's a special beta that I don't have yet. But I know that Robin Glover, the developer SharpCap, has been working on a plate solving built into SharpCap. It's not released in the main release yet, and we try to use the main releases when we can. But The plate solving built into SharpCap is apparently much faster. My friend Pete tells me over there on the Isle of Wight. It's apparently much faster than ASTAP. And you don't have to like remove ASTAP to be able to use the new, what Robin's calling SharpSolve. You can leave ASTAP as a backup. So I think that's what we would do. This was actually pretty fast, you know. It's already figured out that we're 0.15 degrees off. All right, so we're going to put up here on the top NGC 1499, which is the designator for the California Nebula. And let's use our sequencer setting for, I think it's called Prep for Imaging Only. I think that's what it's called, and it changes the the shutter speed to 20 seconds, you know, the exposure, so to speak. Then it dials the gain down to 100. And gets us going on live stacking. So, you know what live stacking is. If you've been on the channel before, there's the first image. You can already see that faint wisp of red there. Let's do our display histogram stretch here and do our histogram stretch in the main histogram, and then back off of our mids just a bit. Boy, you can already see the California Nebula. Let's make the sky just a little bit darker, and that's 40 seconds of the California Nebula. Already really beautiful. This California Nebula is a binocular object. It's about, see, I think in the night sky it is what? Maybe, is it 145 arc minutes? So that would be what? 2 degrees in full, roughly. 2 degrees from bottom to top there. It's a faint object though, but you can make it out of binoculars, and it really comes out well on a moonless night. Ray, good to have you back. We were just here, weren't we? On Tuesday night, was it? Yeah, Fort Lauderdale. That's where you are, Ricky. I should have remembered. Good memory, Tiff. Ty Kim is in Oklahoma. Oklahoma, where the wind goes sweeping down the plain. So, you know, this California Nebula is obviously called that because you can imagine the state of California roughly looking kind of like this, if you use your imagination. But it's actually made up not of beautiful California sand. It's made up of hydrogen alpha gas, and these stars nearby are kind of backlighting it. And it ionizes the hydrogen, makes it glow, kind of not unlike neon light that you might see in a Subway restaurant that says it's open. That's kind of like what we have here, is just the California Nebula being open. And the gases are just moving around and making this shape, but it takes so long for them to move any distances on this scale. How far would you say the California Nebula is away? What do you guys think? What would be the distance? Let's look it up here. This is object number 40. Is it like, it does look like the West Coast, Tiffany says. How far? How far is it? I don't know. I think we're going to have to look it up real quick. Let's go out here to California Nebula distance. 1,000 light years. So it takes light 1,000 years to get here, traveling at, what is it, 187,000 miles per second, I think. 186,000 miles per second. Takes 1,000 years for the light to get here. And at those distances, the movement this gas is making is just not very visible to us. It would take over the period of decades for us to detect any movement. But this gas is very free-flowing. Kind of mesmerizing there, isn't it? You get those mids up very high, and it begins to like define the whole sky as being a mid. Let's look this up in our planetarium software, Stellarium. So we're going to go here and use F3. And we're going to go to NGC 1499. So you kind of see where the California Nebula is. Almost directly overhead. This would be the zenith. Maybe slightly toward the east. And let's put our field of view of our RASA. There's our field of view, that red rectangle. You can see it's so big that it stretches up above our landscape field of view just a little bit. So this is a huge nebula. To find this, you could probably look for you're familiar with the Pleiades, M45, and if you find the Pleiades, then you would be able to look a little bit to the left. So it's actually pretty cool, huh? To have California is right there. I don't know where Stu is. We called this fairly quickly. Maybe we just missed him. All right, so that is 6 minutes, kind of wafting in there. Harrington says, it is a crowning achievement for 21st century observers. Problem is trying to discover where the nebula starts. Oh, wow. Ray's got his RASA 11 on California Nebula as well. If we could just put these together, we'd have a brighter image, huh, Ray? He says it's not uncommon for the California Nebula to remain invisible even through 12 to 14-inch telescopes, even under the darkest skies. I guess because it's so faint. He says, no substitute for experience, or you can just use EAA. And see it. Okay. Well, there you go. We'll snap a quick picture of this, kind of like any space tourist might do. And then use our sequencer to say next target. And let's go over here and just do quick observation of that, because we've seen the California Nebula before, just not in this collection. Now, let's figure out our next object. These top galaxies are for 10 to 14 inch, so they're going to be for very large scopes. Let's break in a little bit at a time here. Let's go to this NGC 1432, otherwise known as Maya. What is that? NGC 1432. You know, I have no idea what that is. And what we'll do is we'll right-click this and then find that line. Boy, I've got to learn where that line is, because this right-click menu is full. Slew to object. There goes a satellite across the field of view. Oh, wow, look at this. This looks like we're traveling in the Starship Enterprise or something. This looks like a cluster, and there must be some nebula in these clusters. You think Maya is one of the stars in M45 in the Pleiades? That's going to be my theory. So what we're doing now is letting the mount do another plate solve, and this just helps the mount establish a better connection to the sky. A real gift, Tiff says, because dual RASA 11s. Catholic 3 DOD, good to have you. New to this. What are you looking for in the sky? What we've got, Catholic 3 DOD, is a list of objects from a book that's called Cosmic Challenge. And this book's by an author named Phil Harrington. And what Phil Harrington does is he tries to help you find a collection of objects you can see with your naked eye, and then with a 3 to 5 inch telescope, then with a 6 to 9, and with a 10 to 14, and then a monster scope, 15 and up. And this particular object, Maya, would be in the collection for 3 to 5 inch scopes. And you can see why. The M45 is really a naked eye object, you could say. But we're going to figure out which star he means. You can already see nebulosity around these stars, and that part you can't see with your naked eye. What you see with your naked eye are you see these collection of stars. Some people call them the Seven Sisters. I don't know which one are the seven. Is it 1, 2, 3, 4, 5, 6? Or is it this one is the sixth? 1, 2, 3, 4, 5, 6. So what's the seventh? 1, 2, 3, 4, 5, 1, 2. Maybe this is 3. 1, 2, 3, 4, 5, 6, 7. Some people confuse Pleiades with the dipper, one of the dippers, because they see this as the handle, and they see this coming around, and they think this is the bowl, and they think, well, see, that's the little dipper. They think this is the little dipper, but of course it's not. It's that would be Ursa Minor over where the North Star is. So this target is M45, Messier 45, and Messier cataloged it so we wouldn't confuse it with a comet. I guess with the naked eye from Paris back in 1765 or whatever year it was that he first saw Pleiades. He didn't want to confuse it with a comet anymore. Now we've got a planetarium software here, and we'll hit. Actually, Pleiades is close enough. Didn't we see it a while ago? Somewhere. Well, we might as well find it now. M45. There we are. And which one is Maya? Ah, the Maya Nebula is the one inside of this isosceles triangle. Isn't that what an isosceles? No. Right triangle. So it's at the right angle of this right triangle. That's the Maya Nebula. It's all this nebulosity around the star that's called Maya. Okay, let's go back to our live view. And sure enough, Here's Maya, and there's all that nebulosity. Now, in this case, the nebulosity is kind of a greenish blue. So we would have to kind of presume that this is more oxygen than hydrogen, maybe, huh? Or maybe it's just dust. And these stars are bright enough that when it backlights the dust takes on a little tint of greenish blue, which is probably more likely. There's not this much oxygen floating free in the universe, is there? It's a vacuum after all. But there could be some. Look at all that space dust. It almost makes like a beautiful portrait, doesn't it? Now that's 200% digital zoom on our RASA. If we wanted to go back to 100% just to see the real optical zoom, it would be right there, and you can still see all that beautiful space dust. Yeah, the JWST is finding even more exoplanets than we knew before. I think we had discovered around 1,000 before. And Tiffany, you're so nice to say it's beautiful. You're an encourager. It is a beautiful nebula. Normally don't think of Pleiades as a nebula, do we? We think of it as a kind of a cluster-looking thing with mainly these seven stars. But in this case, we're not observing it for the sake of the cluster. Harrington has us observing it for the sake of the nebula that's around Maya. So let's go over here and do this quick observation. We'll click the word new observation and let it bring up this observation box. The Maya Nebula showed up from the first 20 seconds. Exposure. Beautiful moonless night. Just accents the space dust. I should say the backlit space dust into a greenish blue. It brushes across the star like, what would you call that? Like dust blowing across a desert at night. Maybe like moonlit dust blowing across the desert at night. And we can almost see the brush strokes. We can almost see the brush strokes. Gorgeous. Let's just see real quick what Harrington says about Maya. This is object 69. These numbers are they're just his numbers. Very arbitrary. Perhaps no lovelier a literary image has ever been painted of their glistening appearance than that penned by Alfred Lord Tennyson in Locksley Hall. Many a night I saw the Pleiades raising through the mellow shade, glitter like a swarm of fireflies tangled in a silver braid. And then in 1859, Temple discovered the nebula around them. He called it a stain of breath on a mirror. Yeah, that's pretty good. Striking blue color. Comes from starlight reflecting off myriad grains of interstellar dust that engulf the cluster. It says you have to have clean, well-collimated optics and a top-notch night. The slightest interference, whether from the moon, light pollution, or passing cloud, will probably render them invisible. Not an optical illusion, but very faint. Here are nebulae, invisible or barely seen in great telescopes, which can be easily seen in their finders. While I might contest his use of the word easily, his sentiment remains true to this day. Talks about the dust cloud. He talks about these little patches. I think we just got into the zenith, didn't we? Look at the way they're moving. Yeah, look, there's the meridian just went by. So our telescope had to stop because it hit the zenith. And if we look up here in the upper right, it shows that it stopped moving. Because see how this checkbox up here in this upper right, the check is gone from the checkbox. So this is what happens when the meridian overtakes our object. It just stops the telescope cold because now the scope is peering straight up. It's a bummer. So what we have to do is go back here to our mount, and we have to go back to the 0 position. And we can watch the telescope traveling back to 0 position in Stellarium. Okay, so it's back at 0 now. Sure enough, our readout of our iOptron commander software shows we're at azimuth 0 and altitude 38 degrees 10 seconds, which is what Emerald Hills is. So with that now zeroed again, we'll just say set current position as 0 position and then enable tracking again. So now we're tracking again and we're ready to go to the next target. So let's go. Let's go back to our objects list. By the way, we'll mark that we observed Pleiades tonight too. What do you say we hit the globular cluster Palomar 2? It's at 77 degrees. So we'll go to Palomar 2. There you can see using the live sky camera, which is a ZWO ASI 178. Is that right? 178? Yes. Folks, I captured Subaru's nebula for the first time a few weeks ago. Need dark skies because it's hard to filter and not lose the blue light. Super, folks. Well, we're kind of charting the same paths here. All right, so we're at Palomar 2. Let's look for that here in our chart real quick. Palomar 2. Palomar 2. Wow, it doesn't have it. Probably has it under some other name. Bummer. Well, anyway, let's go back to here and stop that live stacking, by the way. And let's next target without plate solving. This is going to be Palomar 2. I thought it was supposed to do the next target without plate solving. I guess that's just resetting the camera. Well, I hope we're still aligned after all that meridian stuff, because very easily we could maybe be not aligned after you hit the meridian. Nope, right there it is. That should be Palomar 2 right in front. It's not a large object by any means, is it? Very tiny globular cluster. It's object number 183. It's meant for 15-inch scopes. 183. I always like to try to stretch us because our scope is just 11 inches. But you see, by using electronically-assisted astronomy, we boost the apparent size of the scope by using these special, I guess you could say, like approaches and equipment and skills. Okay, Palomar 2 is a globular cluster in Auriga, 13th magnitude, and it's a particularly nasty cluster to spot because its parts are concealed behind a dark nebula. Spans 3/4 of a degree, and it tells where it is. The dark nebula might not be readily evident by eye, but has a stifling influence on Palomar 2. He says most globular clusters associated with the Milky Way are around the galactic nucleus, so they're referred to as inner halo globulars. There is a second family, however, whose members lie far beyond the galaxy's center and are so known as outer halo globulars. Of all the outer halo globulars known, Palomar 2 is the most extreme, located almost directly opposite the galactic center in Sagittarius, separated by 85,400 light years. It was analyzed in 1997, found to have one of the brightest and most massive clusters in the outer halo. However, it's unappreciated in our telescopes because it's so heavily obscured. We only see a vague inkling of the cluster's true self. Magnitude 13 may be visible in scopes in darker skies, but for most readers, you're going to have at least a 15-inch scope to pull it out. He says in an 18-inch, it's very, very dim for him. Some references still cross-list Palomar 2 as MCG plus 05-12-1. Wonder if we could find it in Stellarium under that number. Let's go try it, because it's not in as a Palomar object. MCG plus 05-12-1. Nope. Well, yeah, look. Our identifier up here in... let me switch back to screen view. Our identifier up here in Stellarium has a CL in front of Palomar 2. That's why I didn't find it a while ago. So it's called CL Pal 2. I'm going to go in here in our object list, and down under the names, I'm going to put that as a synonym. CL Pal 2. And that way, next time when we search for it, we'll remember to look for it under that name. Doug needs to turn off ScopeCam. Yeah. Yeah, the Palomar Observatory is in LA, near to San Diego and inland, right? I drove up to Palomar once, made me car sick. The road was so windy. Anyway, to give you some idea of where we're looking here, for context, it's southeast. And in this case, it's about 78 degrees up. It's so exotic that in Stellarium there is no image of it. But in live view, we have it right here. That's 5 minutes worth. And I don't know if we can zoom in on it. No, it's still going to be very grainy. Very dim. But definitely there. Okay, so let's go over and say, let's see, was it 85,000, right? 85,400. At 85,400 light years, this glob should be brighter. Even though it's on the opposite side of the Milky Way from us. However, Harrington said there's a dark nebula in front of it. That's why it's so faint. Very cool. First time to see this. Cluster Palomar 2 at 7 minutes. Well, it's probably not the kind of, astro image you're going to write your mom about, but it's still pretty cool, isn't it? All right, well, that takes us to another exotic planetary nebula, and it's called PK190-17-1. A nice memorable phrase like that. I'm just gonna type it in like I see it. Oh, did I get the wrong object? I fear that I did. Let me look at up here under top. I'll tell you why this is feisty tonight, because it looks like the sorting is happening like automatically. Why is it sorting like on its own every 30 seconds? There's some setting somewhere. I've accidentally clicked some box that says auto sort. Let's look real quick under preferences, maybe. Preferences, yeah, auto sort, and I need to unclick that because that's kind of unsettling to me. No, that's auto save. So where is sort? Sort. No, I don't even see it here. Ray, do you know where the auto sort is? If you don't know the answer, just ask Ray. He'll know. I don't see it. Anyway, it keeps auto sorting. When it does that, it's like messing with my mind. Just did it again. PK190, PK190-17.1. What a memorable place to visit. Otherwise known as J320 or PNG 190.3-17.7 or Jonker 320. Jonker 320. And it's supposed to be a planetary nebula, but I do not see a planetary nebula anywhere in that frame. Nowhere to be seen. Kevin says it takes 3 hours to drive there. Only takes an hour to get to Mount Wilson. Yeah. PK190, Tiffany. PK190-17.1. Jonker, Jonkheere, like John Deere. Only instead of John Deere, it's Jonker. All right, let's see what we got here, gang. Because I am not seeing a planetary nebula here. Do you think that's it right there? If so, it's going to set the record as being the smallest planetary nebula we've ever observed. Boy, it's a beautiful night here. It's just, you just look up and it's one of those nights in which the sky is just, it looks like somebody spilled a whole bottle of black ink up in the sky. Is that it? Might be. It looks like the globular cluster we were just observing, doesn't it? This is object number 147. No. Wait. It's resorted again. I've got to figure out where that is and turn it off. It's object number 116. Jonker 320. On January 22nd, 1916, while revisiting some of the stars in his catalog of double stars, French astronomer Robert Jonker returned to a vague double in Orion, which he had previously designated as entry number 320. Jonker was later to write of this encounter through the 28-inch refractor at the Royal Greenwich Observatory. I noticed that the object I've cataloged as J320 is not a double star, but it appears with the larger instrument to be an extremely small, bright, elongated nebula. As is the case with J900, this object also appears to be new as a nebula. That must have been exciting. Cross-listed as PK190-17.1 by Pier-Tech and Co-Tech's Comprehensive Catalog of Planetary Nebulae, J320 is in northern Orion. And it tells you where to find it. He says if you observe it under an 8-inch, you should be able to see it because it's 12th magnitude, but he says there's so many stars in the same field, picking out which one is a planetary is a tough job. J320 only measures 26 arc seconds by 14 arc seconds across. This looks like the globular cluster we were just observing. Do you think maybe we didn't clear? Let's clear this and start over, just in case. We're going to clear our live stacking and just make sure. Kevin Gilchrist, these names would never pass muster on Star Trek. Azray doesn't know where to turn off the auto sorting. Tiffany says, aye, Captain Kirk. No, that was the same object. Do you think we didn't slew there? Maybe we didn't move. Because this looks like that globular. Let's stop live stacking for a second. Let's just be sure. PK 190 17.1. It does look like we're moving. So I don't think we'd slewed there. I think that Doug was asleep at the wheel, and instead of slewing, he slept. That's what I think. Catholic 3 DOD is saying he visited Arizona some 30 years ago to see a relative. And at Davis Mothus Air Force Base in Tucson, he was shocked when he looked up and saw a clear night sky and a moon. So huge. That's a cool memory. All right, now we've stopped slewing. And now we see the problem with these stars. Because you're right, they all look alike. Anyway, Harrington continues. He says you might have to use an oxygen 3 filter. He tells you how to find it. He says it looks like a star with two egg-shaped spheres just touching each other tangentially. It's a bipolar planetary. Probably has to take special medicine. However, it might have multiple poles, which would make it a polypolar planetary. Polypolar planetary. Either way, this is the right place. So now we're going to reset our display histogram and reset the large histogram down here, the live stacking histogram. And let's darken the sky ever so slightly. So do you think that's it right there in the middle? Whoop, sorry. Do you think that's it right here in the middle? Let's zoom in. Boy, it's teeny. Teeny tiny. Very teeny tiny. But for this reason, it wasn't discovered until 1916. Tiffany laughed. So 1916, that's just barely over 100 years ago, and all these other objects that we're looking at are like in Herschel's era or Messier's era. This was discovered around World War I era. Can you see those lobes? Look at those lobes sticking out, and then look at that pole sticking out at the top. Now, this pixelation you see those are the actual cells of the camera, because we're at 600%. But zooming in that close helps us see this arm here. And this is why we call it polypolar planetary. Okay, let's all practice saying this 6 times. Polypolar planetary, polypolar planetary, polypolar planetary, polypolar planetary, polypolar. I give up. But anyway, this has got a lot of poles. Let's see if this is in Stellarium. It is PK190-17.1 or J320. Let's go to Stellarium and say F3 J320. Nope. How about PK190-17.1? Oh, it's there. Good old Stellarium. Just when you think it's going to run out of gas. PK190-17.1. Planetary nebula. 12 mag. Man, it's a wonder we're able to even tell. Because he doesn't show, Stellarium doesn't show any of the polypolar planetariness. But it's clearly nebulous. Clearly we can see the nebulosity here. PK190-17.1. PK190-17.1 planetary. Telescopius. We'll see what an astrophotographer found. Polypolar planetarium. I think you've got it, Tiff. Tiff says stunning field of view. Boy, this must be a high-res photo. It's taken forever. I don't know if that's ever going to make it in. Let's go at this a different way. Let's look at it at... Let's just go images here. Look at that. Wow. That's pretty cool, isn't it? Now see, there's a photo. This was taken with the Hubble. And that node, probably this node up at the top, that's one we're seeing jutting out there. Well, I think the picture from the Hubble is better. Well, actually, this column is written by Phil Harrington. How about that? Pretty cool. Back to the live view. I don't know if there's any sense in snapping a picture because, look, here's what the picture is going to show. It just looks like a crowded, starlit night sky. That's like Tiffany said, beautiful. Stunning, actually, is what she said. Stunning. Let me get some of the dark, it's a little darker. And then let's take a picture of it. Because that's pretty cool. Just that planetary nebula is hiding out there in the middle. All right, so we'll say here in the written log entry that this planetary nebula is teeny. 26 by 14. 26 by 14 arc seconds. One of the smallest deep sky objects we've ever observed. Kevin Gilchrist says polar planetary polypolar I can't do it. Okay, next object, back to our object list. How about here's an SNR object. It's meant for 15-inch and greater scopes. Oh, let's try it. SNR 180.0. SNR 180.0 dash 01.7. And that's otherwise known as S147, which I've never heard of. And what it is what does SNR stand for? SNR. Signal to noise ratio. It's a radio. Goes back to, who was it asking about this a while ago? Was it you, Catholic 3 DOD? I forget. Asking if stars can put out, audible sounds, so to speak. And this would be an example of one that emits a radio wave as well as starlight. Ty Kim said that. Okay. Thanks, Tiff. Tiffany, what would we do without you, like, hosting the room? Let's go to this object 184. Oh my goodness. This is crazy. Well, it's also under the name of SMEIS, S-M-E-I-S, which we don't have in the synonyms here. We just have S147. We should put the full name. C-S-I-M-E-I-S 147. What is it? The year 1054 must have been an active one for stargazers. That was the year that the famous Crab Nebula supernova blasted forth, shining brightly enough for Chinese and Native American skywatchers to note a new star blazing near the tip of one of what we now call Taurus the Bull's two horns. The 1054 supernova was so bright that it was visible in broad daylight during the summer of that year and remained visible to the naked eye for nearly a year. Today we know the fading gaseous remnant of that all-consuming event as the Crab Nebula. M1. Some 99,000 years earlier, another massive star in the Bull, Taurus, just 7 degrees north of the Crab, underwent a similar detonation. Our earliest cave-dwelling ancestors could have witnessed the explosive devastation firsthand if it was bright enough to reach naked eye visibility, but there are no records to confirm that. The only evidence we have of that once mighty star is a filamentary debris field that continues to expand around ground zero. None of the classical observers from the 18th and 19th centuries ever spotted those remains. Instead, the discovery of this ruptured bubble of star splatter was made only recently, in 1952, by G.A. Shine and V.E. Hayes at the Crimean Astrophysical Observatory at Simais, Russia. The tendrils of expanding nebulosity are so faint and so broad that it took the light-gathering ability of a 25-inch Schmidt camera to record their whisper. Today, we know it as Simais 147 or S147. Some references, however, prefer to identify it as SH2-240 for its entry in Stuart Sharpless's 1959 Catalogue of Nebulae. So it was just discovered in 1952. Call it what you will, this is a tough target, one tough target. The biggest problem is its huge size, more than 3 degrees across. And for reference, our field of view is about 1.5 to 2 degrees. Can your 15-inch scope cram 3 degrees into a single field of view? Probably not. That's why we need a strategy for hunting down this tough object. And he gives you some strategies for finding it. Few amateurs have seen, or perhaps have even tried to see, Simais 147. But then he says, with a little patience, top-notch optics, and a good eye for fine detail, you just might be surprised at not just seeing a dim hint of this once mighty star, but a patchwork of gossamer clouds interwoven throughout a starry backdrop. If you have a 15-inch telescope, which we do not have, we have an 11-inch telescope. So let's do the best we can. Let's tune up our display histogram. And then reset our large histogram and do a color match. Boy. Are we seeing anything of it at all? Is there a little bit of filamentary stuff going on up here? Would we have noticed it? No, I don't think we would have noticed it yet. But there does appear to be the slightest hint, but it's only a hint, of cloudiness up here in the upper left. Let's find it in Stellarium. We need to make Stellarium a little bigger. And what we're searching for is S147. Not in there. How about SNR 180.0 dash 01.7? Found it. Thanks to the Simbad list. Wow. Get a load of this. Oh my goodness, it's beautiful. Look at that. It's also very huge. Wow. SNR. Now this Stellarium calls it, we'll put the synonym in, SNR G180 0.0-01.7. So it's basically the same number as the SNR listing. Kind of looks hazy. Tiffany, we enjoy you too. Kevin, supernova remnant, right? Isn't that a beautiful? Now, this is not our live view. This is in Stellarium. But wow, look how big it is. This is our field of view. There's a brighter part right here off of our field of view. Let's go back to the live view. And you're right. It kind of looks hazy, doesn't it? Boy, no amount of tuning so far is causing that to pop out after 7 minutes. It is faint. Well, this is the night to see it. Let's hang on this target just a little bit longer. So big. So it's not even listed in the deep sky image annotation and sharp cap. Man, I still think we're seeing a little bit of pattern up here, but after 8 minutes, nothing to speak of. Well, that's why they call it the Cosmic Challenge, right? You guys are troopers. Of course, several of you on the West Coast, where it's 2 hours or 3 hours earlier. Well, in the meantime, let's see if we can figure out where to turn off the automatic sorting in Astro Planner. Astro Planner, how to turn off auto sort. Any way to disable auto arrange and sorting? Yeah, this guy says it's annoying too. Nothing. Boy, searching for help for Astroplanner, I'm finding it sometimes a little difficult because of all the astrological tools. It seems like I get down maybe after the 20th hit, and after that, there's so many astrological tools. Nothing's checked on here. I don't see anything. We already checked edit preferences. Let's go to edit list columns. Nothing. Anyway, let's go back and look at our object again. That's all the way backed out at pure unzoomed 0% zoom. Maybe there's a little bit here. That's after 12 minutes. Maybe there's a little here. Man. Maybe we're starting to see a little dark river right here. But it's not the kind of thing that would have stood out to us, is it? Is it also called the Spaghetti Nebula? It's a good question. Let's go out to the web and ask. SNR 180.0-01.7 S147 wiki. Man. Very little about it. How about if we check under this SIMEIS 147 wiki? Yeah, SIMEIS 147. Just breathtaking. Beautiful. Yeah, also known as Spaghetti Nebula. Let's write that in the synonym. Spaghetti Nebula. How did you know that, Kevin? Yeah, we don't even have the SH2 typed in yet. SH2-240. Boy, it sure is cool, isn't it? Looks kind of like a brain. Supernova remnant in the Milky Way, straddling the border between the constellation Auriga and Taurus. Discovered in 1952, Crimean Astrophysical Observatory by Grigory Shayin and his team using a Schmidt camera and a narrowband filter close to the hydrogen alpha transmission line. It is difficult to observe due to its extremely low brightness. Was part of a survey conducted between 1945 and 1955, most likely using captured German equipment as the observatory was practically destroyed during World War II. The Schmidt camera had a field of view of 175 minutes. Many previously unknown hydrogen nebulae were discovered this way, as they are not readily visible in regular photographs. Apparent diameter of 3 degrees. Whew. 40,000 light years. It spans 160 light years. Man, I don't know how to doctor it up. You can definitely see cloudiness there now, can't you? Yeah. Look at that. I'm not imagining that, am I? Yeah, now look. We're starting to see some cloudiness at 17 minutes. I'm going to put in the observation. If I can find it again. It's so annoying the way it moves its stuff around. Where is it? I've lost it. Can't believe it. We have to find how to turn this sorting off. It just bugs me to death. The only thing I know how to do is to search for it. S147. Can we just go Control F? Find object in contains S147. There it is. Wonder why it won't let me click into this box. What am I doing wrong? Make observation. There we go. S147 might just be our toughest target to date. Reminds me of the, what's that called? That Shark Nebula. Elusive. So faint. 14 hours, Kevin says. Tiffany says, glad they found this beautiful object. Kevin, it was just my guess in searching in Safari. Also adjacent to Messier 37. So supernova remnant. But so big. 3 degrees. The magnitude is spread over the entire object. Ray says, I don't use the Astro Planner, so I can't help. Well, thanks, Ray. I'm not surprised. So what do you use for your targeting software, Ray? What do you do? Just search for them in something like Stellarium? Or use Nina? Because if I remember right, you're mostly doing astrophotography. Boy, I don't know if we would have 14 hours on this object. We're up to 22 minutes. But you can start to see now some degree of, what would you call it? Just cloudiness, like Tiffany said. If you pull it to the right of that crest and the big histogram at the bottom, now you're starting to see some rivers of, oh, look, like right here. Yes, right there. Yes! So we saw it at 23 minutes. At 23 minutes, after straining, we caught a glance of the first hint of the tendrils. Reminded us of the California nebula, only in strands. See right here? Right over here. Starting to see it now play out. Let's make this part just slightly darker if we can. And then pump the mids up even more. Can you see this puff here and that arc? Yeah, Tiffany says, I bet it's cold out there where you are, Ray. Ray uses Nina or SharpCap search. Gotcha. Look at that arc starting to come into view. Got it. Ray just uses Google search and then get the location. And look at this little arc here. And up here, another little tendril's coming out. So 23 minutes is what it took for us to see something that few amateur astronomers have ever seen in their lives. And honestly, I was beginning to wonder if we would ever see it. Look right here in the middle. There's a little red, barely visible red strand. Look at that red there and that arc. Let's go back and look at the... So see, what we're seeing is this kind of an arc. Or maybe this. So there's that arc. And then this is right here. And then here we're seeing this circle, which is that. Right there. That's amazing. It took us 26 minutes. So Ray controls the telescope from inside as well. And then this tendril here must be like this. And then up here we're starting to see that strand, which is this. Here we're starting to see that strand. We're not going to see this brighter part because it's off of our field of view. Kevin saying, woohoo! It's all so faint, though. It would never have leaped out at us. All right, let's go ahead and call it, and let's do one other object before we quit here. I'm going to save this just in case the photo reveals something, although I don't think the photo will reveal much. As Harrington put it, few amateurs have ever even looked for S147, let alone observed it. There's so much latency on the typing. I'm basically just typing by feel, and the words come out like 30 seconds later. It's so latent. Well, let's see here. Might as well try for this object 182, which is UGC 2838. UGC 2838. UGC 2838. Object number 182. Yeah, I think you're right, Ray, with maybe a dual band filter might bring that out more. But boy, this filter I have that's kind of designed for the RASA 11, I just don't have the kind of money to spend, you know, on these filters. This filter was $600. And I just hate to mess with it, you know, because you can spend so much money on filters. But this Celestron, I think it has about 6 notches in it for 6 different starlight, you know, narrow windows of light to let in. And the other thing is, when I put in a filter, I would have to, if I replaced, like if I took out this Celestron filter, I would have to recalibrate the RASA. And man, I just hate having to deal with that. Well, this is behind Pleiades, isn't it? We were already here once tonight. We should have done that while we were here. But I didn't know that this was going to happen. Anyway, the thing we're looking for is a galaxy, strangely enough. UGC 2838. UGC 2838. Oh yeah. So how will we find this? Pete was making fun of me the other night because we were doing star patterns. You remember? We were saying, okay, so we're going to look for these 2 stars. And he called it human plate solving. Oh my goodness, Kevin, that's like the biggest gift anybody's ever sent over YouTube. How did you even do that? Is that possible to send that size gift? That's amazing. $49.99 through that little, whatever that's called, super chat, I think it's called, a super chat gift. Tiffany says, Kevin, you rock. We all agree, Kevin. That's amazing. You know what Kevin's doing? He's pitching in toward a new filter. He's saying, let's get this guy that special filter. Ray says he uses a filter drawer. I can't remember if this thing has a filter drawer on it. It might not. But even if I did a filter drawer, even if I just move it the slightest, it's half the width of a human hair is all it takes to get it out of alignment. I just didn't want to mess. Kevin, that's amazing. Thank you so much, brother. I tell you what, as far as a cause goes, why don't we apply this toward trying to think of some universal cause that we can all identify with. Kevin say a filter. But I want to help somebody. What about helping the people in right on the border between Israel and Gaza? Somebody who's lost everything. Let's do that. Somebody who's lost house and home and mother and father and hope. And let's invest this in somebody who's hopeless. So we'll do that, Kevin. Thanks to you. Thank you so much, brother, for cheering us along. Okay, so anyway, I was looking at these star patterns the other night, and Pete was making fun of us in a cheery way, saying it was like humans plate solving. So he came up with a way. Ray's going to go change his filter. He came up with a way, and what he did is he installed a script. I'll have to look and see how it works again in Astro Planner, because at the time we did it in Stellarium, but he made a way to do it in Astro Planner too, and I'll have to learn about that. In Stellarium, he said, let's see, how was it? We hit F12, didn't we? Uh-oh, I was highlighting Astro Planner when I hit F12. In Astro Planner, we hit F12, and then we had to load the script. Oh boy, there. It's called Doug's Sharp Cap Deep Sky Annotation. And then once we loaded the script, we need to be right on this galaxy again. Let's look for it again. F3, and it was UGC 2838. Now with that galaxy highlighted, with the script loaded, we hit play. And it gave us this output. Remember that? Now we copy that to the clipboard. We go over to SharpCap and we say Deep Sky Image Annotation, and then we take this Paste Custom Object Info and we click it. Why didn't it work? Must not have had it copy to the clipboard. I did not. Okay, let's try to copy it again. We're going to go back to SharpCap. Oh, I think we had to go to output. Yeah. Now we go over to SharpCap and we say Paste Custom Object Info. Still didn't do it. Now we've got it in the right place. Oh. Maybe it did it and it's just not in the field of view. It should be called PGC 13696 or UGC 2838. But I don't see it. So that might mean doesn't think it's in the field of view. But now wait, in Stellarium, let's do the human plate solving trick again. If we can find see this arc of stars? That's this arc of stars. So you get to the end of this arc of stars and it comes out here. And then the galaxy is almost in line with this double that double shining through the second star in the arc. There's a trace of 5 stars with 3 stars in front of it. Boy, I wish our... Hey. Why didn't it work? We are definitely getting the script output. And here, paste custom object info. What am I doing wrong? Objects nearby. UGC 2838. Otherwise known as PGC 13696. Oh, look, it's definitely putting it in. It's just, it thinks it's off the screen. Tell you what, let's turn off deep sky image annotation for a second. And let's say plate solve, solve only, so that it retakes a shot. Kevin says, use as you think best, Gaza. Hey, I live in LA. Filters are required. Kevin, Doug, your heart is in the right place. Doesn't hurt that I have a horrible head cold and I'm having my glass of hot sake. That's funny. Tiffany, feel better soon, Kevin. Sake, yum. SkyCam view. Are we on SkyCam view? Thank you, Tiffany. Sorry. Well, it wouldn't really hurt much because there's not been anything to see yet anyway. Okay, now let's put on deep sky image annotation. Oh yeah, look. So it was working, we just needed to resolve. Now let's zoom in slowly, because this crosshair has been copied in from Stellarium. It wasn't there originally. Let's zoom in slowly. Because it thinks that galaxy is right there. Now, everybody memorize where that is, and let's take... And right there it is. So that works! Pete, if you're watching this after you get up tomorrow, because, you know, he's in UK and he has to sleep during the night, but if you're watching this after you get up tomorrow, this worked exactly! And I think you have a way to do it in Astro Planner that's actually easier and more precise. I just don't know how to use it yet. Anyway, here's this galaxy. It's UGC 2838. And it's object number 182. Even with the galaxy's field isolated from the cluster of stars, The background sky is still brightened by the glow of M45's nebulosity. Averted vision and lightly tapping the side of the telescope tube to impart motion should help to overcome that handicap, but only if the sky itself is dark and transparent. He says, I've seen UGC A2830 through my 18-inch reflector, but only after I'd spotted the galaxy initially with the 10 millimeter. Trying a 5 millimeter eyepiece dimmed the image so much that the galaxy faded from view. Guys, I'm telling you, all of that goes away with EAA. Just use EAA and you can see the stuff that otherwise is impossible. This is magnitude 13, but magnitude 13 is scattered throughout the whole edge-on disk image. Not much to photograph there. We're at 264% of our optics. So a photograph of this is not going to show that much. But through observational astronomy with EAA, you are observing that galaxy in a way that very few have. So we're going to go here and do a new observation. And we're going to say Pete's script worked great to help us immediately zero in on the exact portion of the sky where this galaxy was located. We didn't have to do human plate solving. Never again. Thank you, Pete. Once we ran the script and punched in the value into SharpCap, we saw the tiny sliver of this edge-on faint fuzzy beauty. It's kind of remarkable that we're seeing what an 18-inch would normally be required to see. EAA rocks. All right, gang. That's probably a good place to stop. I want to thank you guys for being here on short notice. And Kevin, thank you especially for that amazing encouragement. Yeah, it reminds me of the Needle Galaxy too, Kevin. You're right. We're going to use this funding to help somebody right on the border between Israel and Gaza that's lost everything. And we're going to pray for peace. Thank you, Lord, for making all these cool objects. We especially love that supernova remnant that it took us 23 minutes to be able to see the first tendrils, but we finally did. We love being able to see this stuff that it would normally require a massive 18-inch scope to see, and we have 11. We love it that God makes this stuff. We love the family nature of team-oriented astronomy like this. We love the community online here. If you want to go to emeraldhillskies.com, you can sign up there to be on an email mailing list. And we'll email you like we did tonight about an hour before the live stream. We emailed people and said, let's just do this tonight, 10:30 Eastern time. So sign up for that email if you like, but you can also click subscribe on the YouTube channel. And if you are a YouTube user that's logged in, it will ping you when we start a live stream. If you also click the bell, that's how you let YouTube know that you want to be notified when one of these live streams start. Only if you want. Doesn't cost you anything, but nevertheless, only if you want. If you like content like this, if you want to hit the thumbs up, it does help to raise it in the heads-up displays of others. I have a big day tomorrow at work, but I just could not pass up this black, inky black, moonless sky, and I'm thankful to you, whether you're viewing live or whether you looked at the recorded version of this. Thanks for being here. God bless you. We'll say goodnight to everybody. And Tiffany, thank you for kind of hosting the room. And Kevin, you're right. It's near Electra. All right. God bless you guys. We're going to call it good night, and I hope you have a great weekend. I'll talk to you soon.